Hello. Today I will be going over Section B of the 2012 Calculus BC practice exam. And so this will be the calculator section of the multiple choice part of the exam. So if you want to try and solve these problems along, you're going to need a standard graphing calculator. Alright, so the first one, number 76, we're trying to find which statement about this graph, f, is false. So let's take a look at A. F is continuous at x equals 0. So we know that f is defined on every value from -2 to +2. And so there's not going to be any discontinuity here. And we can see that the limit from both sides, as f approaches 0, it's going to go to the same point. And so we know from that f is continuous. So that's a true statement, so we can rule out A. For B, we don't exactly know. We don't have enough information as to whether f is differentiable or not. Like, we don't know the slope exactly of this graph, so we can't tell if it's differentiable. So we'll skip that one for now. As for C, having a critical point at x equals 0, so what a critical point means, let me write this down. It means that f prime of x changes sign. Okay, so basically what that means is on the left side of 0, of x equals 0, we can see that the slope is going downward. So f prime is going to be negative. It's going to be decreasing. So it's minus on this side, but on this side it's going up. It's going like uphill. It's increasing, so it's going to be a plus sign. So there is a critical point at x equals 0. We can find that from the graph, so it's not C either. Number D, f has an absolute minimum at x equals 0. So what this means is that we want to find the lowest point of f. And since we know that f is only defined on -2 to +2, we can see that the lowest value, the value at which f hits its lowest mark, is when x equals 0. And we can see that by looking at the graph, so it's not D either. And then for E, we want to see if the concavity of the graph changes. So what concavity means, it's the sign of f double prime of x. So whether f double prime of x is positive or if it's negative. So if we look at the graph on the left side of x equals 0, we can see that the slope f prime, it starts out like around 0, and it gets steeper and steeper in the negative direction. So f prime is decreasing when x is less than 0. But that's the same thing as saying f double prime of x is less than 0. So it's going to be concave down here. But if we look at this side, this is the slope starts out at 0, and it kind of increases. The slope gets steeper and steeper and steeper. So f prime is increasing here, which is the same thing as saying f double prime of x is greater than 0. So this is concave up. And so as we can see, the concavity changes on both sides of this graph, so E is true. And now that we've ruled out all of the answers but E, we have no choice but to infer that f is differentiable. So B is our answer. Awesome. Okay. So number 77, we have two functions, e to the x and x to the 4th. So now what it's asking is, when is the rate of change of f greater than the rate of change of g? So rate of change is the same thing as saying the derivative. So let's find these derivatives. F prime of x, well, e to the x is going to be its own derivative. So e to the x, that's not going to change. But g prime of x, we can use the power rule, and we can get 4x cubed. So now, since this is a calculator question, we can pull out our calculators and graph this, which is what I'm doing right now. And so now we can look at these answers from what we can see from the graph. Here, I'll try and draw it out. So e to the x approximately looks like that, and 4x cubed basically looks like this. So what we want to know is, when is this function bigger than this function? So we just need to find this point, and it's going to be negative infinity to this point. Then it's going to stop. So we can rule out e, because we know that it changes. And so if we find it, if we try and graph the intersection point, we get x is approximately 0.831. And so we can see that negative infinity to 0.831, that only shows up in one answer, and that's answer B. So we're going to go with that, because for the reason why A doesn't work is because that's when the rate of change of g of x is greater than the rate of change of f of x. But we don't want to know that. We want to know the opposite. And so we can infer that B is our answer. Okay. Number 78. We have a piecewise function that we need to take the integral of. So let's try and simplify this integral. So this will equal 3 times the integral from -1 to 9 of f of x dx. And then we can use the reverse power rule to get 2x, but we have to evaluate it from -1 to 9. So let's write that again, but we'll simplify the right side. Okay, so 2 times 9, we're going to do the fundamental theorem here. So 2 times 9 is 18, and then we minus 2 times -1, which is -2. And that'll just equal 20. Okay, so now all we need to do is find the area from -1 to 9. So let's start out with these big triangles from 3 to 9. So this triangle, this small triangle on the left, is going to have a base of 2 and a height of 2. So how we find that is we take the base times the height and we divide it by 2. And that's just going to give us 2. So this area is 2. And then this big triangle over here, this is going to have a base of 4 and a height of 2. So this is, again, 4 times 2 divided by 2, and that's just 4. Okay, so our top is going to be 6. And then we're going to subtract whatever this area on the bottom is, because it's below the x-axis. So we have this little triangle here with a length of 1 and a height of 1. And so that's going to be 1/2. So this triangle has an area of 1/2. And now we have to find the area of this big rectangle. And so this has a length of 3 and a height of 1. And so that's just going to be 3. So 3 plus 1/2, that's 7/2. So this equals 12/2 minus 7/2. And this will equal 5/2. So we know that this integral here is going to be equal to 5/2. So let's plug that in. So 3 times 5/2 plus 20. This will equal 15/2 plus 20. And so since this is a calculator question, we can plug that in. And what we get is 27.5. And that's our answer. So letter C is our answer. Awesome. So number 79, we have a Taylor polynomial question. So automatically, since it's about x equals 3, we can rule out A and B, because those are Maclaurin polynomials, and we need to have the term x minus 3 in every term of the series, because if it were a Maclaurin series, it would be x minus 0, and so on. So we can rule out those two. And so now we need to find the Taylor polynomial, like the general form. So this will be f of 3 plus f prime of 3 times x minus 3 plus f double prime of 3 x minus 3 squared over 2 factorial, and I'll add one more, plus f triple prime of 3 x minus 3 cubed over 3 factorial. Awesome. So we know all of the values of the derivatives of f at 3, so we can plug these in. So this will equal f of 3 is just 2 from the problem, and we minus x minus 3. So this doesn't immediately rule out any of these questions, so we'll keep going. So f double prime of 3 is 6 plus 6 x minus 3 squared over 2 factorial. And so 2 factorial is just 2. So the coefficient of this is just going to be 3 x minus 3 squared. So that rules out C. Because in C, you're not dividing by the factorials. So now we just need to find the last term. So f triple prime of 3, this will equal 12, or I should say plus 12 x minus 3 cubed over 3 factorial. And so we know that 3 factorial is 6, and 12 over 6 is 2. So our last coefficient is going to be 2, which rules out D, and that makes D, our answer. Awesome. 80, we have another question about analyzing this graph. So we have the graph of f prime here. And so we're going to analyze these 3 statements and see if they're true. So first of all, statement 1, f has a relative minimum at x equals negative 3. So what a relative minimum means, let's review that. It means that f prime of x equals 0 and f double prime of x is greater than 0. Because that means that it's something like this. And so this would be the relative min of the function, which implies that it's concave up, which is what the second statement means. So that's the definition of a relative minimum. And if we look at the graph at x equals negative 3, we can see, since this is f prime, this equals 0 here, but the slope, it's going upward, it's positive. So that does fit both of these descriptions of a relative minimum, so we know that I, or 1, is true. So now, statement 2, the graph of f has a point of inflection at x equals negative 2. So what an inflection point means, it means that f double prime of x changes sign, or f prime of x goes from increasing to decreasing, or vice versa. So if we look at the graph of f prime at x equals negative 2, we can see that f double prime is almost going to be 0 here. But if we look, for it to have an inflection point, f prime has to go from increasing to decreasing. So the slope has to change from positive to negative. And what it does here is it goes to 0, but the slope is never negative. It never goes down like that. It keeps going uphill. The slope is still positive. So it doesn't switch from increasing to decreasing. And so that means that 2 is false. So we can rule out this one and this one. And also this one. So we just need to find out if 3 is true for us to decide between A and E. So what concave down means, it means that f double prime of x is less than 0. So we only care, in this statement, we only care about 0 to 4 of f of x. So we're going to ignore the left side of this graph, and we're going to look at 0 to 4, and we can notice that it's just a constantly downhill slope. It never goes uphill. It never increases. We can see that it's constantly moving. The slope, the tangent line, is constantly moving down. It's facing downward. And so we can confidently say that f double prime, the slope of f prime, is going to be less than 0. So 3 is true, and that makes it E. That makes our answer E. Awesome. So for 81, this is another function characteristics question. So we're looking for the x-coordinates of the points of inflection on this graph. And so, again, what inflection point means, let's recall back, we want f double prime of x to change sign. And so the only time that we can see that it does that is at x equals 1, because it changes from negative here to positive here. And the other definition is f prime goes from increasing to decreasing, but we can't tell just from it being negative. It could be negative and increasing, it could be negative and decreasing. So we know nothing about f prime. The graph of f doesn't tell us anything. So the only time we can be confidently sure that it has an inflection point is at x equals 1 only. So that's going to make B our answer. Cool. Oops. Let me get rid of that. So 82, we want to find the average value. And so the formula for an average value, or av, that'll equal the integral from a to b of f of x dx over b minus a. That gives us the average value over the interval a to b. And so when we plug this in, this will be 0 to pi over 2 of the square root of cosine of x, and we'll divide that by pi over 2 minus 0, which is just pi over 2. And so since we can plug this in to our calculator, which I'm going to do right now, so that's 2 over pi times the integral from 0 to pi over 2 of the square root of cosine of x with respect to x. And what I got, it should be 0.763, which is indeed our answer, which makes it C. Great. So 83, we want this function to be continuous at x equals 3. So we need to find which one must be true. So for A, f of 3 is less than the limit as x equals 3 f of x. Well, this has to be false because let's say if we had a graph, we had a hole at 3, and this is f of 3. So it's kind of backwards, but the limit is going to be here, and obviously this has a jump discontinuity here, or a removable discontinuity. So this is not going to be continuous, because if f of 3 doesn't equal the limit as x approaches 3 of f of x, the function's not going to be continuous. That's what the definition of continuous means. So we can rule out A as an answer. For B, what it's saying is that the limit as x approaches 3 from the minus side is different than the limit as x approaches 3 from the plus side. Well, if that were the case, it would look something like this. This would be the graph. Like, let's say this is the x-axis, this is 3. And so, obviously, right here, this is going to be one limit, this is going to be another limit, but right here, it's not continuous, because you can't see how I like to define a continuous function is if you can draw it without having to lift your pencil up from the paper. Like any kind of function that you can draw without having to lift your pencil up from the paper. And so this, you have to jump from this point to this point. And so that's called a jump discontinuity, and so it's not continuous. So we can rule out B. So C, f of 3 is equal to the limit as x approaches 3 from the minus side, which is also equal to the limit as x approaches 3 from the plus side. So in this scenario, we have this point, f of 3, and we have the function here, and the function here. So the limit, it approaches the same point, and that equals f of 3. Well, that's what the definition of continuous is. So we can confidently say that by definition, continuous means that C is going to be our answer. And just to clarify for D, a function can be continuous without being differentiable, such as the absolute value of x. Looks like this. So obviously it's continuous for all x, but it's not. You can't differentiate it at x equals 0. And also the derivative, for a function to be continuous, the derivative doesn't have to be positive or negative at any point. So yeah, C is our definite answer. 84, we want f to be a so we don't know f, but we know f prime of x is e to the x to the 4th minus 2x squared plus 1 minus 2. So we want to find when f is concave down, and so that means f of double prime of x is less than 0. And so let's go ahead and find f double prime of x. Well, this will just equal e to the x to the 4th minus 2x squared plus 1. But now we have to multiply by the derivative of this inner argument, and that'll equal 4x cubed minus 4x. Awesome. So if we graph this monster function on our calculator, times e to the x to the 4th minus 2x squared plus 1, what we get is a function, so it looks kind of like this. So let's put negative 1 here, let's put 1 here, and it looks like this. So it's like a curve. So our zeros are going to be at negative 1, 0, and 1. Those are when it changes sign. And so when it's below, we want to know when it's below, so it's going to be negative 1.5. Since we don't care about all real numbers, we just care about negative 1.5 to 1.5. So it's going to be negative 1.5 to negative 1, because it's going to go down. It's going to be below 0 until it hits this 0 point, and then it's going to be above 0 from negative 1 to 0, but then it's going to dip back down from 0 to 1. So we can say 0 to 1 is another interval that f is concave down. And so when we look at these answers, only one of these fits this description, and that's answer D. Negative 1.5 to negative 1 and 0 to 1 are the only integrals. Jeez, I keep saying integrals instead of intervals. Sorry. The only intervals on which f is concave down. So number 85, we have the fuel consumption of a car, f of s. So 6e to the s over 20 minus 6 squared over 2400, or s squared over 2400. So we want to find the rate at which, so we want to find df ds. And so let's just take the derivative of this. So this will be, first let's multiply by the chain rule. So the derivative of s over 20 is going to be 120. But we have to remember that s, see, its speed is changing at the rate of 20 miles per hour squared, so we have to put ds dt in there as well, because of chain rule. So the speed's changing. S is not a variable like x, where it stays constant in the problem. It has to, s is changing, so we put ds dt in there. And so then, using the chain rule again, we get 2s over 2400 times ds dt. And now we multiply by the original equation because it's an e to the it's an e function. Awesome. So from the problem, we know that the car is traveling at 50 miles per hour, so s is 50 from what we know, and its speed is changing at the rate of 20 miles an hour squared. So we know that ds dt is equal to 20. And so now we can plug s and ds dt in and solve this big equation to find df ds. So this will equal df ds. This will equal 20 over 20. So that just cancels out. That's 1. Our first term is 1 minus 100 over 2400 times 20. We'll simplify this later. And then this will be times 6e to the 50 over 20 minus 50 squared. That's going to be 2500 over 2400. Okay, so now we can just plug this all in to our calculator. We get 1 minus... Alright. And feel free to do these problems along with me as I plug them into my calculator. 50 over 20 minus 2500 over 2400. And so our final answer is going to be approximately 4.299. And hopefully that's an answer. Yes, it is. It's answer B. So hopefully that kind of made sense. That's a related rates problem. So that's cool. 86. So if f prime of x is greater than 0 for all real numbers, and the integral from 4 to 7 of f of t dt is 0. So what we want is we pretty much want, so let's try and visualize this. So let's 4, 5, 6, 7. We pretty much want f of x to be, we want the integral to be 0. So this area will cancel out this negative area, and this will be 0. So we obviously want the values to increase from 4 to 7. So A, that works, and it also works for B. But for C, it decreases. It goes up from negative 4 to 6, but then it decreases from 6 to 3. And so we don't want that, so we can rule out C. And for D, it's not really increasing at all. So we can rule D out too. And for E, it's not ever below 0, so this area is always going to be positive. So we can rule out E as well. So we just have to decide between A and B. So let's try and graph out these functions and see what they kind of look like. So 4, 3, 0. The problem with this one is that it doesn't ever go above 0 on the interval from 4 to 7. And so for the integral to be 0, it has to have some positive area and some negative area. So we can confidently rule out A, and we can say that B is our answer, because if we graph it out, 4, 5, 6, 7, 4 is going to look like that, 5 is going to look like that, and 7 is going to look like this. So it'll pretty much, this area will pretty much cancel out, and the integral will be 0. And that's the only one that fits that description. So B is our answer. All right, 87. We want to find the cross sections of this function, ln of 3 minus x. So to set up this area, or this volume, V, we want to take pi times the integral from a to b, and in this case, a is 0 and b is 2. And now we want to have high minus low. So normally it would just be V equals integral from a to b, pi, of high minus low squared dx. And so our high in this case is ln of 3 minus x, and our low is just the x-axis. So we can just write ln of 3 minus x squared with respect to x. And so we can plug this into our calculator now that we've set up the integral. Pi times the integral from 0 to 2 of ln of 3 minus x squared dx. That's going to give us 3.233, which is answer D. Pretty simple equation. Nothing scary going on there. Awesome. So 88. So the derivative of function f, so f prime is increasing for x is greater than 0, and x is less than 0, and it's decreasing for x is greater than 0. So that's the same thing as saying that f double prime is greater than 0 for x less than 0, and f double prime is less than 0 for x greater than 0. So we want to find a function that kind of fits these requirements. And so we want to find where the concavity of the function kind of changes. So if you'll remember, concave up kind of looks like this, and concave down kind of looks like this. So this is when f double prime is always increasing. See, it's going from, the slope is going from really low to really high here, and it's going from really high to really low on the concave down side. So automatically we see that A is pretty much concave up because the slope is just increasing. It gets to 0 here, but it keeps increasing. So A is concave up for the whole interval. The concavity never changes. And same thing for B, the concavity doesn't change, it stays concave down. So it's not going to be A, it's not going to be B. For C, it's kind of tricky because we want f double prime to be greater than 0, so we want it to look like this. Basically just want it to look like this and then this. It's like a piecewise function. You know, we're taking the first half of this concave up thing and we're piecing it with the second half of the concave down thing. And we can notice that that really looks like answer E, and that kind of makes sense because if we take the slopes here, we're seeing that it's getting closer and closer to 0 as x goes to 0. Like the slope, it flattens out, which means it's increasing. It goes from negative to 0, which is increasing, but then it's less than 0. It starts at 0 and goes negative, keeps rolling down the hill for x is greater than 0. So E fits all our descriptions, and we don't really have to analyze C or D. Cool. So 89, it's a particle's acceleration, a of t. So we want to find the velocity at t equals 3. So if we remember, v prime of t, the rate at which the velocity changes, is by definition the acceleration. And so we can kind of use that to our advantage. And so what we kind of want to know, what we want to give here is v of 3. And how we can get there is by setting up a start plus change problem. So final equals start plus change. This will be equal to v of 0 plus the integral from 0 to 3 of v prime of t dt. So we know from the problem that v of 0 is 5. And now, let's rewrite this. Integral from 0 to 3 of a of t dt. And we're given a of t in this problem, so we can kind of plug this into our calculator. 5 plus the integral from 0 to 3 of x plus 3 over square root of x cubed plus 1 with respect to x. and that equals 11.710. Awesome. So that's our answer E. Pretty simple problem. All we have to do is pretty much set up a start plus change. Awesome. I'm gonna write this 6.710 equals 11.710. Cool. So for number 90, we have a series that converges, and a of n is greater than 0. So we know it's not an alternating series, because otherwise a of n would be greater than 0 and less than 0 and greater than less. So for a, this is what the ratio test is, but the key thing here is that it equals 0. So basically what the ratio test is if the limit as n goes to infinity of a of n plus 1 over a of n is less than 1, the series converges. And so it doesn't have to be 0, it just has to be less than 1. So if this was like, if the limit was 0.5, that would still work. So the reason why a is false is that it's equals 0, not less than 1. For b, again, absolute value of a of n is less than 1. We just know that a of n is greater than 0. We don't know if it's less than 1 or not. We just know that it's bigger than 0. So we have no way of knowing how big a of n is, so we don't know that. C, this is just asking if the series converges to 0, which not necessarily. We don't know. We're unsure on that. We just need more information. And for D, n times a sub n, that's going to converge as well, because if a of n is greater than 0, if you multiply this by n, it doesn't really change anything. It makes the series a bit bigger, but if a of n is greater than 0, it's not going to change the sign. It's not going to change the convergence. So it doesn't diverge, which means this is false as well, which leaves E to be our only option. And that makes sense, because a of n over n, same thing as multiplying by n, dividing by n won't change the convergence of the series. Okay, 91. So this figure shows r equals 2 cosine of 3 theta and r equals 2. So this circle out here is r equals 2, and this kind of flower shape inside is 2 cosine of 3 theta. And so what we're going to do is we're going to find the area of the circle minus the area of this. I'll try and draw this flower thing. And so the area of the circle, to set up polar area, we do, so a equals 1/2 the integral. And so because this one goes full circle, we're going to do 0 to 2 pi, because we're in radians, of 2 squared d theta. So that's our first part. That's our area of the circle. And now this area of this flower shape. So this doesn't actually go from 0 to 2 pi. This just goes from 0, and then it equals 2 when it's pi over 3, then 2 pi over 3 here, and then it goes back to pi. So it's actually only minus 1/2 the integral from 0 to pi of this whole thing, 2 cosine of 3 theta squared with respect to theta. And so we set up this integral. Let me kind of calculate that. Again, I'm kind of going into these problems blind. So 0 to pi, 2 cosine of 3 theta squared d theta. That's going to give us 9.425. Okay, awesome. So that's our answer D. Yeah, so that might trip a lot of people up with the integral from 0 to pi instead of integral from 0 to 2 pi. But if you graph that out on the polar mode in your calculator, you'll see that for theta equals pi, r is going to be, it's going to go full circle. All right, so last multiple choice question. H is differentiable, and h of x equals h of 2 minus x. So for statement 1, it's saying that the integral from 0 to 2 of h of x is greater than 0. And I don't think we have enough information to really infer about this. So 1 is false just because we don't, h of x could go below 0. It could be completely negative, and we have no way of telling just from knowing that h of x equals h of 2 minus x. We would need to know some values of the function. So 2 says that h prime of 1 is equal to 0. And so we can kind of take the derivative here. So h prime of x is going to be, so let's take the derivative of this right side, h prime of 2 minus x. But now we have to do the chain rule, which just multiplies by negative 1. So h prime of x equals negative h prime of 2 minus x. And so h prime of 1 is going to be negative h prime of 1. And so we don't exactly know if this is going to be 0 because we don't know what h of 1 is. We don't know any of that. So we're unsure on 2 as well. And so for statement 3, we want h prime of 0, which is equal to h prime of 2, which is equal to 1. Wait, hold on. I think I might have made a mistake here. H prime of 1 equals, oh yeah. So if h prime of 1 is equal to 0, we can add an h prime of 1 to both sides here. Sorry, I just made a mistake. So 2 h prime of 1 equals 0. So h prime of 1 has to be 0. So 2 is true. Sorry for that. That was my mistake. And for 3, we can see that h prime of 0 will be equal to negative h prime of 2. And so that, by definition, contradicts 3. So 3 is false. And that makes B our only answer. Awesome. So hope you guys enjoyed this multiple choice section. So next up will be the free response questions for the AP exam. So thanks for watching.